All right. Hi, everyone. Welcome to another edition of the PAC Meetup. The lockdown is still almost there, I think, depending on the country where you're based. So in France, they started to open up a bit. So my kids went to school Tuesday. We'll be back tomorrow. I don't think we're going to call it school because it's more like a kindergarten where they're making sure that they're doing them homework, but at least for the parents it's a way of having less things to manage, so it's pretty cool. So again, another pack meetup. Today we have a special theme that has been brought up by one of the attendees of our previous meetup, the IoT performance testing. We've been involved from a Neotys perspective in several projects. So I know part of the dark side of the IoT space, testing a platform or testing the backend and testing the apps, but there's still a missing gap. I think how can we test getaways and how much sensors we can handle on the getaway. So I think I'm pretty excited to have this meetup where so today we know that we never had the chance to come to finish the meetup in 1 hour. So today we're gonna go to 1 hour and a half. Of course, I will start the conclusion a bit earlier because we know that the conclusion takes forever. But here it is. Also to remind you, for all the one that you're connected, there's still, we have 2 more PAC meetup. We are promising to finish the month. So PAC meetup will be until the end of May. So next week will be our not the last big pack meetup, but you have still a chance to win an Amazon gift card. So if you want to select a topic for our next pack meetup, please submit a topic. There will be a link posted on the chat. And we will pick tomorrow one of the theme. And for the last one, obviously there will be no game because I will select directly one of the theme that I'd like to discuss. So no game, no way to winning any Amazon gift card anymore, but still we will have we will all still have fun and discuss about performance. So when I pushed that theme, a good friend of ours that has been several times to our meetup, Luca, which is here today. So Luca, how are you today? You're muted, but yeah. So you're here.
Fine, thank you. Ready for this meetup.
He said, "Hey, why don't we invite the Steve Jobs of the IoT, the one that is changing the world for building IoT apps." So it's really an honor to have the founder of Arduino. I don't know if I'm pronouncing it well, but I try to do my best. It's Fabio Violante. So it's Fabio. It's really great to have you on board and have your insights on the IoT space. How are you today?
Thank you very much, Eric. I'm fine. We're still locked in Milano, but the situation is improving quickly. And it's a big honor because, you know, performance is my passion. I started my professional career working with performance testing, measuring, monitoring, from university to creating a startup and etc. So, and now I'm at Arduino, so I'm changing my perspective because we went from computers to very constrained devices, and we can talk about a little bit about this.
Otherwise, with me, I have other PAC members. With me, of course, we have Jahn from the UK, which is big followers of ours. So Jahn, again, thanks a lot to be here. It's the Kiwi living in England is here back again. How are you, Jahn?
I'm very well, thanks. Glad to be here again, as always. Very interesting topic, very relevant, very current. And we're still on a journey, I think, with IoT very much in terms of how it's going to evolve. It's spreading into every aspect of life. So the necessity for such devices to perform, remain available, becoming more and more important. And they have the unique challenges, as Fabio was pointing out. So glad to be here.
Otherwise, we have Alexander Podelko again back. So how are you, Alexander, tonight?
I'm fine, thank you.
Great. We have one of our pack ladies that is back. It's Gayatree. Gayatree, it's great to have you on board again. How are you, Gayatree, today?
Doing great here, Henrik, and very honored to be part of this meetup series. Hope I'll be providing some insights, and I'm sure there are a lot of experts out here, so I'm really here to learn more about others' perspectives, and definitely a great topic to be selected for this meetup. And this is an emerging one, and with the situation we are in, definitely makes a lot of sense. Thank you.
We have Rob live from the Massachusetts. Rob is working from Dynatrace, and he has tons of customers. And I have one in my mind. I hope that Rob could give me more insights about it. So, hi, Rob. How are you?
I'm great. Thanks for having me. Yeah, excited to be part of this again. So, not sure how many customer names I can actually mention, but certainly there's more and more data collection from these devices, and Dynatrace typically focuses on kind of the back-end processing and the applications and the end user experience from the data. But we're definitely seeing more and more data coming in from devices. So I think it's a great topic as well.
We have live from Mexico. It's Senor Performo. Senor Performo, the master of OBS. How are you?
Hola, amigos. How are you doing? I hope everybody is safe and healthy, and very glad to be back here and having an opportunity to share a little bit on these new challenges of performance testing with the IoT. It's going to be a very exciting meetup, webinar, talk, conversation. And so let me get some coffee.
To start this discussion, so I'd like just, for those who's not familiar with IoT platforms, there are obviously 3 different layers that you probably have to consider when you work in the IoT space. There are the apps that will connect and consume some or control or consume data that has been sent over. There is the IoT platform, which is receiving messages from the various gateways and sensors that have been processed and analyzed and so on, and that will be exposed to the apps. And last, of course, on the bottom of the architecture, you have the real sensors discussing with usually gateways. So I think there is 2 different dimensions in these discussions. There is the performance problems that could be observed from the backend perspective. So traditional performance testing or performance engineering on the IoT platform. So how many messages it can receive, how many apps can consume. And that's one dimension. And I think from here on that side, we are pretty much we are used to, or at least for those who have been working on that dimension, it's quite similar to a traditional load testing project. But then there is the other dimension, which is pretty much challenging in its how can I make sure that gateways will behave well, that will receive all those messages from all those hundreds and thousands of potential sensors. If we take an example of a parking lot or a ship having containers with sensors to track where those containers are located at the moment. So those gateways are receiving tons of messages, and they have to be able to send all those messages in time. So I'd like to first cover that topic by discussing about the sensor part. And for that, we have the chance today to have Fabio Violante. So I'd like to have his opinion on what things we should consider, what would be the recommended approach if we need to simulate or test or size properly getaway. So I think having Fabio is great. So he probably have a lot of great insights to share with us tonight. So Fabio.
So Eric, thank you very much. So the key point here is that the perspective that we have as software engineers or people that belongs to the traditional operation, even the modern operations world, DevOps and so on. So we normally are getting used to have like gigabytes, terabytes, GPUs, super processing power, and so on and so forth. While and I was coming from this world, so it's a world that I know very well. I've been CTO for BMC, so for performance and availability at BMC for 5 years. So I'm pretty familiar with that world. When I jumped to Arduino, then I understood that there is another dimension, that is the sensors dimension that you mentioned, where a lot of other things become important. And to some extent, there are still performance problems, even though there are different kind of performance problems. Among the problems that I started facing, because Arduino is famous for these kind of products, for the Arduino Uno, that is mainly a prototyping board, but not many people know that we have a range of products that is used in industrial application, not only for prototyping, but also for production. And what I realized that more and more people are developing Arduino-based IoT nodes, as well as other kind of technology based on embedded system, because the key point is understanding that there is a difference between nodes that are based on microprocessor technologies. If you think about the Raspberry Pi or a normal computer that is microprocessor based, and nodes that are based on microcontroller technology, like the ones we do, where other aspects are important, like battery duration, reliability, boot time, security, where you don't want to patch millions of devices on a chip because there is a security patch on the operating system. So all these other aspects are becoming very important. So when it comes to embedded system, then we probably, in my opinion, one of the most important key performance factor to help people with is energy management. Because energy, as far as the processing power for the device and the sensor, is very little, but when you combine the sensor with the telecommunication technology, then energy becomes a real challenge. So as you may know, in our space, we have these local networks, Bluetooth based or Zigbee or this kind of protocol, but you have also long range, low power technology like LoRa, like Sigfox, narrowband IoT, Cat-M1, this kind of technology. And then you have the more power hungry technology like
LTE.
GSM, LTE, 4G, 3G, all the Gs that you can imagine, and even Wi-Fi. They use quite a lot of energy. So one of the key challenges that we have seen in the reality, more than just processing the messages, is understanding how this coupling between the node, the technology, if there is a gateway involved, the type of technology that we use for radio communication, and then the gateway towards the core network, how this kind of end-to-end performance becomes more crucial. And this is particularly important because there is one point, and then just leave the word to you for more comments. But basically, if we think about the future, everyone is anticipating trillions, billions, whatever devices. But what we are seeing is the reality of the boards that we sell and the uptake that we are seeing on the market. So IoT is becoming a reality. With COVID, just to give an example, with COVID, we saw a number of companies that converting their production to make, touchless soap dispenser. It's a simple application, but they need to know when the soap finishes, for how long people are washing their hands. So we are engaged actively in thousands and hundreds of thousands of device deployments, where they're using our boards as a sort of Swiss knife to connect all this stuff with some form of connection. Then it is really, really important to understand that with these millions or billions of devices, there will be a skill shortage as far as who is capable of developing software on those devices. So already there is a skill shortage as far as software developers, like regular full stack developers. But if you go to the embedded and electronic engineers, this number is very small. So we need to find ways to help those software engineers that are approaching embedded system development to understand all the intricacies, because the solution could not be only to put a Linux distribution on a tiny devices, because it doesn't fit, it doesn't have the characteristics, it doesn't support the power consumption that is needed for running a device in the field for months and or years. So this kind of things calls for a new category, let's say, of products, so that look at performance 360 degree, not only throughput, transaction times and things like that, but also thinking holistically to everything that is needed.
So, for example, how long would that code be run on a device without charging the board, for example?
Or helping people to understand what could be the sampling rate for a value, because in many cases our sensors, so this board is called BLE Sense. It is packed with sensors. We have digital microphone, we have the accelerometer, we have barometer. We measure everything with this board, but depending on the sampling that you do for the sensors, the battery lasts from 1 day to 2 years. So having tools that help people understand these type of things without having to do, sophisticated profiling of the code and being expert is something that is a very intriguing and very complex challenge, in my opinion, for the performance specialist like you are.
So Jahn, you raised the hand, so probably Jahn, you have a small comment about what has been said so far, and I would have another questions for Fabio after your note.
No, that was very interesting, Fabio. I was just thinking aloud, as you say, the challenge of having the skills to write this embedded software in a very, very efficient way with so many things to consider about, as you say, the impact on power consumption, and simply the ability, I suppose, to update it on a regular basis. I mean, you buy, and at the moment, I think a lot of the options are you buy another version of the device or the latest model. I was just thinking aloud, if technology would, if it was feasible, not now, perhaps, and it's only in certain use cases where you could leverage something like the container model, where effectively there's it's almost the firmware embedded software is running like a container, and then managed from some sort of orchestration. So it's taking that sort of concept, and then you've got sort of, if you've got 10 devices, 100 devices, 1 million devices, you sort of have that sort of immediate control ability to influence the version of the firmware, push updates out, all assuming there's an internet connection also associated with these devices, which invariably there is for many of the IoT devices that come under the IoT banner. So I'm just thinking if that sort of thing would be practical in the future. It just seems like obviously it's lots of devices talking back through a gateway to some sort of central hosting for things like smoke alarms, the sort of household products, which we're talking obviously is more specialized, but to sort of make that the ability to centrally control and manage right down to the software that's running on the devices, I think would be something that would be attractive, although how practical it would be to implement, who knows? But
absolutely.
I don't know.
Yes, it is absolutely important, and we also are doing a big effort at Arduino, but many companies are doing this kind of effort as far as firmware over-the-air updates, secure updates. So we put, for example, crypto chips on every single device to ensure security, because security is the other aspect that people tend to forget about IoT. But there are some attempt at creating like a more sort of virtualized framework.
Yeah, that was
this kind. On top of these devices, there are devices like I don't know, the new one that we released, the Portenta, is called Portenta. So I don't want to do like many commercial, but just for you to know. So we do have devices now that have the capability of running multi-core architecture. So even in microcontrollers, so you can run Python on one of the cores. Portenta is the one we announced at CES. So it's really beautiful. The box is beautiful, but you can only pre-order it. I think in May we're gonna in May you can get it, but it's so you can run Python, for example. So you can open the space of interpreted languages on one of the core and keep the real-time part in C++ on one of the core of the architecture, still in the microcontroller category. So it's very promising. There are multiple attempts. There is JavaScript as well. So what we did, for example, was unifying the engine for JavaScript and Python. And this is something that we are going to announce in the future. So we're doing a lot of efforts in this direction that you mentioned. But from the central point of view, is for sure a challenge because, you know, sending updates securely, scheduling things in order to avoid disruption of the service. So it requires an entire new set of things that people today are, you know, not facing at all. So they're just saying, okay, how can I technically do a firmware update over the air and look at the constraints, like I can send only 25 bytes per minute. So doing an update. So this kind of things that people forget, but when you are on LoRa, there is not much space left for extra stuff. So minimal delta updates is important, and protocols, efficient management of the gateways, because they are clogged if they have to update tons of stuff, one packet at a time. So it's a huge challenging environment. It's a different thing because, you know, so far we were looking at performance in gigabyte and terabyte, and now we go back to bytes, and it's incredible the jump you got, because, for example, not many devices run even an operating system. So our devices, like the modern devices we have, the one that are equipped with the ARM microcontrollers, Cortex-M4 for those of you that know the technology, and Cortex-M7, they do have a real-time operating system. We standardized, so we layered the Arduino on top of the embed operating system, real-time operating system. But many devices in the world, they don't have any sort of operating systems as far as embedded systems are concerned. So even multitasking or disruption services are quite possible, and they're quite complicated to handle.
So I have a small question. So you said that you open up to JavaScript and Python and more modern interpreted languages. So if let's say we have new developers say, hey, I want to invest my time and build IoT application implementations using Arduino. If I do everything with let's say Python, would that consume more power than building everything with the traditional C language or C++?
So the answer is mixed. So what we are doing at the framework level is trying to be very cautious in the way we do the libraries and the interfacing part, because as far as the interpreter, it's quite predictable, the consumption of energy. So it's probably a standard Python code is more efficient than a C code written by a non-expert in C. So it's quite strange, but you know, computers do a better job than humans in some cases. But we are not at the point where there is something that is very standard and very efficient as far as Python and JavaScript is concerned. So still a lot of work. We're trying to sponsor a couple of initiatives. We are talking to the different players in this space with the founders of the different MicroPython initiatives and JavaScript and this kind of languages, in order to take care of these kind of, let's say, secondary aspects, but that are crucial aspects. So today, you know, a well-written C++ code is better than a normal average, let's say, Python code, but a not so well-written C code is worse than an interpreted program written in Python. So it's quite strange, but yeah, this is the situation. And we're trying to support those languages, even though Arduino is quite simple, as you may know, because you told me that you were using Arduino a little bit, but it's quite simple because we try to simplify and strip down all the complexity of C and C++ framework down to the bare minimum, and also we incorporated a lot of complexity into the libraries that we developed. For example, for low power, we have a low power library that hides a lot of complexity, but still, you know, you need to know what you're doing. So we're working actively on this, and probably in 1 year from now, 1.5 years, you will see very good frameworks that allow you, depending on your skill as developer, to pick the language that you prefer and go for a similar solution. But there is a huge need for performance expert and power expert to work on those frameworks, contribute to those frameworks, because there's a lot you can add.
So, Senor Performo, you raised the hand, so you probably have a small comment. So I'll let you.
Well, it is very interesting on what Fabio has been mentioning, and made me thought a lot on what we have been seeing lately as performance engineers in the priority that we're getting on some being careful in performance optimization for front-end and web environments. It's very similar to what he's saying, because we are not so much focusing on slamming the backend servers, making sure that they are responding, which is a very important piece of the solution IoT. But as well, here we have, let's say, sending most of the functionality to the IoT device, to the Arduino, to any of the other brands that are there, smart fridges, Alexas, products that integrate like this. And you got to be really careful, as we were saying in other sessions, where that the JavaScripts are not huge, that the CSS are well assembled. You really need to take into account CPU cycles, what is happening. And as you mentioned, some of the metrics that we were not used to taking into account in performance testing in a while. I haven't been paying attention to temperature, power consumption, and things that are really crucial on these IoT devices, and that the performance engineer goes very much in hand with a good developer that needs to understand all the layers that are from the very top of all the languages that are interpreted on top of others, as it has been mentioned, a clean, just not C# or C++, just plain C code being well written, being well optimized, or going even deeper, assembly or assembler code, or things that really truly force you to think of, well, I have this, let's say I have Java on top of those levels, and I have this class that is not well optimized, that probably is instantiating unneeded objects and is consuming some memory here and there. On IoT devices, you have to be really careful, and those little things that if a performance engineer doesn't know about these things that we are not so used anymore to pay attention to, it's going to be very difficult to detect some of those things, because as Fabio was mentioning, some of these libraries you have to take into account by the millimeter or 10th of an inch for the USA, what is the use of resources that you are doing, and optimize it as much as possible, because a little bit of waste will decrease not only the speed of response time, which will be, I want my smartwatch to go as fast as needed, but just a tiny, and the software on it has to be tiny as well, as optimized as possible. And not only that it responds fast, as I mentioned earlier, that it doesn't start to heat up and burn your wrist, or that it can last more than a day of power in your smartwatch, which I hate on most of smartwatches, that they have to run some of the Google watches that have to have all the Google functionalities. Probably you're just using 10 of them, but all of them have to be running on the device. And that's why the battery doesn't last so long. Like some of the other devices that like, hey, I'm just counting your steps, your heartbeat, and this and this and that, and that's it. And I'm gonna last for 7 days, 5 days, other than just 12 hours with some of the other smartwatches. So the range of things that you have to pay attention with IoT in terms of performance is wider, way bigger, I would say, than what we are used to in many other just web end-to-end solutions that we're just automating scripts to slam them.
No, I think you mentioned something that is very important, because you have to go back in some cases, in many cases, you have to go back to really the basics of what of the problem you're facing, like interrupt. So I think we forgot as performance engineers about interrupts.
CPU cycles.
And CPU, in many cases in this kind of devices, a lot of features are performed at the sensor level. So take Bosch or STM Microelectronics, that are two brands that are friends of us, but we use a lot of brands, but for sensors, we mainly standardize on STM and Bosch because they have fantastic sensors, and the pressure sensors they are crazy, but there is a lot of logics that runs, or the accelerometers, they have a lot of logic in the sensor. So they trigger the microcontroller only when it's really needed. So this means you can save a ton of energy. So you can run on microwatts or nanowatts where you are on deep sleep. And these kind of features are important. So sorry guys to go to these kind of details, but when we talk about IoT, it's not only gateways and concentrating stuff, because we have such large pipes that sending 24 bytes, or I don't know, we can send whatever. We stream videos in real time, 4K for video games now to the cloud. But when it comes to the real problem, if we want to talk about the challenges of people in IoT, in my humble opinion, we have to tackle these problems because they're very complicated. So how to model this stuff, how to write code for this stuff, how we can simplify the experience for people, how can we provide frameworks and tools to test those devices without being Einstein. So these are the challenges, in my opinion.
And I would say on some of those, it's crucial to understand the sizing on some of those pieces, when the size of information that the IoT devices are sending is not the same as an online video game experience with your PS3 that you're sending tons and tons probably on your device. You don't need a 10 gigabit Ethernet card on your smartwatch. You just need something that is capable of transmitting a couple of bits per second, and that will be more than enough, and optimizing some of the other resources. And this area, the performance design, you have to take into account so many other things, and not like I have 16 gigs of RAM in my laptop and it can run whatever, I don't care. You don't have that on your wrist, on your ring, whatever type of IoT device you are working with. Probably it's a Tesla that is a big ass computer on itself, or it's just a tiny little thing. The size and matter will be hugely different. I am guessing a Tesla would require a huge amount of bandwidth, and this guy doesn't, just a tiny bit. You have to take into account all that.
Yeah, but I think depending on the implementation, if you think about connected cars, I remember there was I'm not going to name the brand, but it's a German popular car manufacturer that wanted to have a standard of cars sending messages saying, oh, this driver is driving not as usual. So he's maybe he has drank too much, or maybe there's a flat tire, or there's something dangerous. So the concept was to that car detecting misbehavior and alerting the other cars that maybe would be self-driving cars, say, hey, pay attention to that driver. So here, I think even it's small bytes, or it's going to be tons of messages, potential messages processed and sent over to the surrounding. And then also those, the other cars needs to process that information and react in the right time. So I think it really depends on what type of implementation we're talking about. If it's like a fridge, I mean, I don't care if my fridge is not sending the temperature at the second. I think it doesn't matter. But I think if there's a life involved, I think here we're more concerned about how fast those messages have been sent and received and processed. So I think that's my perspective, for sure. So Luca, you raised your hand. Luca, you want to say something?
Yeah, I have two comments on that, on what Fabio and Senior Performer was saying. So the first one is that it's very funny to think about. We have to going back 30, 40 years when COBOL programmers have to take care about having no resource at all, or having a resource that costs so much. So they have to take care about every single line of code and be very, very effective. Because in terms of performance, what we can see, and I think you agree all, when we look a lot of Java codes or high level programming codes, we see that right now we can say that developers are quite relaxed in terms of used resources because there are no constraints at all. So Fabio says we are talking about terabyte of RAM or something like that. And every time that you install a software, also on your laptop, it requires 4 CPU, 6 gigs of RAM, and so on. That's a huge amount to only run Word or something like that. So that's funny, because I think in the IoT space, the lack of capabilities is also required a changing mindset, because we have to come back to pay attention a lot of little things that, as mentioned, it could change the life of a device in terms of battery duration and so on. And that's quite funny for me. And the second aspect is that in terms of what we can see on performance, and of course I talk about our company, what we are doing and researching. We understand there's a lot of improvement that we can add, especially when we talk about compilers or runtime compilers or similar, because we are obsessed by configuration and flags you can set, and the huge number require you to try to fix and set them to have more and more performance or lower resource usage. So we are also working on this space in terms of performance in order to using AI to identify the best set of flags that results in a compiled code that use less resources, for example. And that, I think, will be another interesting area of where if we came back to the last part where we say when AI can help our performance, is exactly working on the idea of change or automatic discovery the best configurations in order to save battery, use less resources, or improve your network connection. That's another interesting thing we are working on.
So I think it's a great way of introducing the question I had in mind, and I wanted to ask that questions. It's just that there's a standard called Open Telemetry, and I know a few years back I went to Dun & Trace Perform, and Dun & Trace Perform were announcing that one agent, and there will be like a open one agent where people can code and implement one agent within the IoT stack. And I will be pretty much interested in let's assume that we're able to install an agent on a small board or a sensor, because how can we track the memory used, and how can we track the battery used? How can we track all those things that matters depending on how we implement the solution? So Rob, I know that you have a couple of customers that has implemented a pretty cool IoT implementation. So I'd like to have your insights on that.
Sure. Can you hear me okay?
Yeah.
Okay. All right. Yeah. So we, I guess there's kind of a couple parts to that question that shares this topic. I guess Open Telemetry, maybe we'll start with that one. Just for us, it is a great way to have an open way of distributed tracing. Dynatrace has had a proprietary kind of patented tracing for many years, but we are also pushing a lot to have Open Telemetry be a standard. In fact, we actively participate in that and contribute code and things like that. But that's really going to allow, kind of these types of devices to be able to not have an agent, like you said. So it's going to be embedded code, an SDK, something that's going to produce those, telemetry messages, and then we can stitch them together, through the tracing IDs. So we're going to bring that in and just kind of have, again, that visibility of distributed systems and be able to hook it from the device back into the backend system. So I think that's definitely what we see. I think that's what's happening. That's why it's pushing for it. Kind of maybe on the other kind of just insight. Yeah, there's customers that, I'm not going to name specific names, but I think this one's kind of a cool one where there's a major shipping, commercial shipping for stuff, and what they've done is use devices on the doors. So similar to like Disney with their little watches, you can have a device that's on you, the passenger, and as you walk over the place, you can kind of approach your door. It'll actually know who you are, automatically update it, and so then these devices, which is the door, are constantly being monitored. So if you can't get into your door, or you can't, even worse, escape out of your room to get out of the door, and you're relying on this actual device, that's kind of a high risk for the passengers. So those are constantly being monitored, and then proactively, you know, taking that data, like, is the door healthy? Is it locked? Is it working? Does it need to be patched? And then that can be alerted on to the support staff to go actually fix that door problem for the passenger. So it's kind of like a great passenger experience, kind of walk up to the door, boom, you're in your room with security, but then you also have to consider the maintenance aspect of it, and being able to have these things be reliable and working and functioning, and have that tied into the other you know support services. So it's not just collect the data, it's tied in, and then be able to have it tied into the you know, the IT support, which then can also go into maintenance and other groups. So yeah, so kind of a long-winded answer, but yeah, I think there's kind of two things to kind of recap. Yeah, open telemetry, definitely how things are going to get connected, but then kind of, you know, things are all connected. Things don't live by themselves. This data ties back into business systems, you know, IT systems, and then also the business and IT processes to, you know, that's part of the ecosystem.
So I'd like to have the feedback from Fabio, because if you start to have a process, so you have limited resources, so if you start to have one process that is grabbing data continuously on the board or on the sensor, and sending it back to somewhere to track how the sensor is behaving, I guess from your point of view, there will be a major constraints on the battery usage of the sensor. So what is your opinion on that first? And the second one, have you, from Arduino perspective, thought about how could we bring a monitoring dimension to all those sensors, give more visibility to observability to when you implement that type of projects?
So this is a very complex question, because of course on many devices, especially end nodes, like constrained end nodes that have battery challenges, it is a real problem. So just to give you an idea, a lot of people have to shut down the LEDs because they consume too much. So even an LED that just tells you that the device is turned on and off could be interfering with the functioning of the device in terms of consuming too much battery. So it's very challenging. So what we are trying to do is connected also in general to the way we are approaching the IoT device programming. So we are trying to create a cloud platform where we generate a lot of the code that goes into the device, so that we can instrument a lot during this code generation in standardized ways. But of course, all the telemetry is always a trade-off between what you can do and what the device can do, power consumption, different type of application, if it is battery powered, not battery powered. So we're trying to be very, effective by generating the code. So when you write the code, you can define the profile of the device where the code is going to be deployed, so that you can understand what can be done and what cannot be done. And what we're trying to do is to strip down to the bare minimum, although we're trying not to do custom stuff. We're trying to obey to some protocols and to respect some protocols, standard protocol like SIB or SNML. So we're trying to use these kind of protocols as far as the data that are going forth and back from the cloud. But it's from the performance point of view, it's complex, because not only all the devices, and this was also something that we are adding gradually to our devices, have all the native metering capabilities. So in some cases, you have to derive these metrics from other metrics, and this consumes more energy. So what we're trying to do is to get to specialized devices that we embed about the hardware, from the hardware point of view, into the device, so that we get the raw measurements. I don't know, the charge of the battery is a complex parameter, believe it or not, but it's a complex parameter to monitor. Also, because one of the challenges in IoT is that the customers, they want the cheapest devices ever, but they want them packed with a lot of features. So they want to pay $1 and then get everything from it. So from the protocol point of view, what we're trying to do is to use very efficient protocols and use the cloud to do this conversion between, let's say, the bare minimum number of bytes that are needed to convey an information into something that is meaningful. And the way we're trying to do to avoid the complexity of the software to explode is to manage these translations in the cloud, so that we could do the code generation that goes into the device, so we know how it was applied, and then we translate the number when it comes back from the device. So this is the approach we're taking, but it's a very complex issue. It really depends on the application. So you made a good point before, because if you're talking about a Tesla or an autonomous driving car, and if you have a 5G network, it's a different category of problems. The problems I'm referring to are mainly related to microcontrollers type of application, low power constrained, low cost, low power application, not let's say $5,000 computers that is on the Tesla.
Yeah. And so you made the thing with the clouds. Now I understand more, because I followed you your website several times, because I was following the Arduino Uno project and other things. And now I went back once Luca told me that you may come, and I say, hey, what is this IDE on the cloud? So I didn't get it. So I started to look at it, and now I get it now. So all the idea is about you build part of the code, and
Yes.
then you manage that on the device. That's pretty cool.
Yeah,
So
it is what we are doing on the cloud side, for example, because we have the IDE, that is the online IDE. We have the traditional IDE and also Pro IDE, but the online IDE is the development tool. But it's important also the cloud part. So we have the Arduino IoT cloud with the idea to enable everyone to create a cloud code that I don't know, can interface with Alexa in a few minutes by generating all the code. And that's the idea. So you just define the properties that the device import and export, and we do all the boilerplate for connecting, for low power management, for telemetry, for everything on our side. So limiting the number of intervention by the users. This is the philosophy we are applying to the code.
So that opens me a big idea. So if you give me a connector, and I am talking from a Neolode standpoint, and I say, okay, now I want to drive all your sensors that are registered in your cloud or in your cloud account. So then I can basically send you an order, say, hey, I want that sensor to send a message. I want this one to send another message. So will be feasible?
So today we are not. So this is sort of tied with what Ian was saying before. So of creating this sort of virtual layer where you create a sort of more flexible device. What we are enabling now with the next releases of the cloud is the over-the-air update. So it will be possible to say, send this to that device and that to this number of devices, to downsampling or sampling on the devices. So you have some probes that you can decide who they are and what they do. So we are enabling this kind of scenarios. So far, it's mainly by changing the code. So you deploy a different firmware on the devices. But in the future, I sort of envision a world where the ability to execute interpreted and containerized code on the devices allows you much more flexibility on changing stuff and also sending orders. Today, a lot of code in embedded system works. Is a sort of, we go back, millions of years ago with RPC, with this kind of opcode and things like that. So for example, think about the architecture I was mentioning before, the Portenta is multi-core. So talking between two processors is now made using a RPC mechanism between the two cores. We have architecture where we use all the Unix style mailboxes mechanism. So you have to go back. So even today, you can change the way the device works by sending some specific opcode to a routine attached to an interrupt. So it's you go back to a lot of the basic concept of computing, but they become important. And more importantly, I think, is the fact that depending on the condition and the surrounding and the context where the device is deployed, performance may change dramatically. Reflection on the radio, ability to get a good signal, GPS signal. You can have the same battery last 1 year or 15 minutes. just because of the surrounding stuff. So its performance becomes very crucial.
It reminds me about mobile testing. So if I install my app and I receive SMS and WhatsApp, and I don't know, someone calls me, would I be able to process the payment, or would I lose the payment? So it's about the same thing. But still, I think you just told me something that is amazing. So while you were speaking, and we're sending the partnership contract as we were speaking. So we need to build an integration so that I can control your devices for sure. That would be great. And also that opens the door to you can imagine that you have like a stream or open telemetry a port from the cloud where you can stream out the various metrics that you receive from the various sensors that you're coordinating to any other monitoring or observability platform like Dynatrace or others. I think there's a big potential on that. I have a question for Alexander. So I know Alexander, for me, has always been a master on capacity planning and various things in the market. And when I look at this, I said, hey, if we do some code, Alexander, do you think that there will be a way of opening another dimension to do some capacity planning on those sensors? Especially we were talking about on the battery usage and so on. Is there a way to sort of predict how that sensor behave based on the various parameters? Would you think that this is something we could add and recommend to the market?
I am sure that probably something there, but I actually would like to talk a little bit on another topic, because I wouldn't consider myself expert on sensor and what we can do inside the device, and we already spent at least 50 minutes talking about these front-end edge devices. What I would rather want to mention that what struck me in IoT systems, that in addition with all these problems that we discussed before, it's just another level of sophistication of the whole system. It is not just sensors and how we get it, although due to lack of standardization and a lot of variability with this device, we have a lot of challenges from performance point of view. But actually, the system becomes very complicated. We need to get that all communication between sensors and gateway, or then we get somehow keep all this information with kind of streaming. We need to query that information. So it actually adds complexity to our kind standard of, say, business application. With introduction of this real world, we move to next level, and it becomes very difficult to actually test the system or monitor all this part. Makes sense getting all this information from different part of the system. So it brings to new level of complexity. And probably looks like we have a lot of different work and discussing how we can test specific side of that system, but very few for the whole system, and it is difficult because you need to approach it from different areas. So when I didn't work too much, but once I did a review of the topic. Actually, I will share the link with the result of this review.
It's on the chat for those who's not
yes.
aware. So Alexander just posted a link on the chat.
And what struck me is that it had become very complex and difficult to digest, and maybe that is place when we need to get back to kind of modeling. So we test different parts of the system, get partial information, and then somehow need to combine that information to get the whole view of the system. I haven't heard and seen much about that moving in that direction, but it looks like it's become so complex that we need to move into that direction.
So Gayatree, you just raised a hand and you didn't so far interact with us. I really like you to interact with us. So please.
Yeah, definitely. Thanks for the opportunity to opening up my comments here. And, as you all spoke about and what Alexander also was leaning towards, the IoT of things, definitely, these are very complex, right? Not similar to what we have been testing the websites, and the usage of these devices differs from how the websites are being used. So with this complexity involved, and there are many other devices in its way, right? The networks, the gateways, different speeds of the networks, different components involved. So it's very complex, and you don't know where to start and how to even get, measure these things. So for me, what I've thinking about is to start with simple things, breaking it down, like first identify which in this whole network, in this devices, which is the most critical component, right? Which fails and where it will impact the user or the device in whatever failure scenarios. Analyze that and then prioritize. In these 3 steps, just see how you can simplify and try to see which is a component that is testable and how it can be testable, right? Also identifying the failure scenarios here. So some of the failures may be okay, like, some device doesn't work, okay, it's something wrong with that, you maybe battery down, or you have to go to the, the repair shop to get it checked what's going on. But then think about the devices which are in the medical healthcare system, and think about the devices just in the cars, the sensors in the cars. So I had some of the experience where my car sensor was not, it was raining and the sensor just opened the tailgate. Well, it was not intent to, but then these are some of the ways where we have to understand the failure scenarios and how it can cause an impact to the user and to the device and to the network, like what it can cause into the entire system. So while this is very difficult to test and even to measure, right, coming up with the SLAs or SLOs for each of these components or end to end, it is very complex, and getting to these definitions and trying to understand what is important, what is the scenarios that we can live with, and what is the scenarios that is absolutely it has to work, like 99.99%. So these are some things you have to kind of identify these, analyze, and come up with the plan or the strategy, how you are tackling to test it, right? And also to add to that point, how we want to test is what I was proposing or thinking of an idea is of like now we have clouds available in different locations, right? So that way, one aspect where if we have to drive a load from different locations, so using the cloud, that can be taken care, part of it at least. And then I was thinking as a performance as a service, right? You have PaaS, SaaS, IaaS, so all of these as a service. Why don't we have a performance as a service where you provide the service to anybody, any customer, any company who are trying to implement these IoT of things, and they don't have the infrastructure, they don't have any of these things, but they would like this to be performing very well. And they would like to know when it fails and how it fails. If it fails, what happens to their system, right? So along with that is the collection of the data. Now, your device is working fine, but what data it emits, you need to have, as Henrik and everybody was saying, the telemetry of aspect of it. So now you have this artificial intelligence, the machine learning aspect we can take and try to collect these data through that technique, and just trying to see the trend of it, or just making prediction of the data, so how it will perform, what it does. So these are various aspects, that one can implement. It's not just one fit size all kind of solution. You have to kind of use these different technologies at various points and try to come up and try to solve the problem, right? So there are definitely challenges with new things. And lastly, what I would like to say is the training aspect for anybody getting into this world. What are the resources available? How do I even know what is the Internet of Things? And what are the technologies? What are the different protocols, right? And what are the different tools available? If not available, how you can like take the open source tools, how you can use or add to that open source tools and make it usable for these Internet of Things. So this is all involves most of the Internet of Things for the performance testing that I wanted to share.
Yeah, I think you made a point. I mean, KPI is I mean, traditional response time doesn't make sense. If I want to measure the response times when, let's say, I have a modern car that has we've been involved in different implementation of IoT on cars. Let's say I have a mobile app and I press the button to warm up the car. So I press the button. So the app shows me that the car is warming up, but in real life, it's not instant. So the message goes to the IoT platform and goes back to a gateway, and the gateway ships that to the sensor, and sensors spin up officially the car. So there is almost, so the thing is just measuring the response times, the end-to-end response time, how long it took from the moment this particular user press on the device to say, hey, please warm up my car, and that the car has officially was startup. It's very hard to measure. So in some projects, I'm referring to MQTT because it was the standards. You can add the not restricting on the payload that you're sending, so you can add an extra information with the timestamp, and then the timestamp goes to overall architecture, comes back, and then you can calculate the response time. But this is not very standard. It's like abusing of the fact that it's allowing us to add some extra properties in a payload. You're changing the number of bytes that you exchange in network. So it's not really a real testing. It's just you made a trick or a hack to measure that. So I think this is really tricky, especially how can I measure the end-to-end, because the lack of visibility. I mean, we are fishing for those type of metrics, especially the customer says, hey, I want to track that. I want to measure. When I track that, I want to follow that car and get the GPS location live. There is still a lag. So how can I measure that? This is questions that coming up and very hard to answer. And at the moment, as of now, I don't think there's a clear answer because there's no standard that we have in the web space where we start to have more standards, at least in measuring and providing the right KPIs to the market. Luca, you want to say something before? You raised your hand before.
Yeah, talking about capacity planning, our experience showed that there are some tricky things that happens and make the creation of models about capacity planning harder and harder, so challenging at all, because in terms of the load profile that is part of the first of the two business and technical KPIs you have to correlate to create models. The load profile is very strange, let me say, because we are not talking about the user on a system that are doing something and creating requests, but we're talking about devices. Sometimes devices that communicate to the final, let me say, to the final cloud or via a gateway, not directly, but using other devices as an open because they are too far from the final destination. But sometimes the message arrives at the gateway. So in terms of gateway, you have a number of sensors that are giving you a lot of messages, sometimes duplicated messages, sometimes messages are dropped, there are packet loss, handshake connection issues. So the load on the same gateway that is serving this same number of devices with exactly the same number of messages sent could be very different according sometimes also to the weather. So the impact, the distance of the messages sent. So in terms of creating the right load, profile load, both in performance testing or in capacity planning, is harder and harder. That's our experience in creating the model. So we cannot trust the same assumption that we use when we generate a mathematical model to address forecasting, for example, in order to sizing an infrastructure. So that's another point that I think we will have to take care about, because it's quite weird try to figure out how we can really understand which will be the load, the business load, let me say, that the device is generated on a final, let me say, end destination that can be a gateway or the cloud.
So before I want to ask that question to Fabio, but before that, I just want to remind to the attendees that there's still a 50 euros Amazon gift card to win. So there is a link in the chat. So if you want to win 50 euros gift cards at Amazon, submit your topic for next week, and the one that will be selected could win that gift cards. So Fabio, so you mentioned before that you were coming from BMC, so I'm pretty sure that you're quite familiar with the capacity world if you're working at BMC. So and then Moviri and now Arduino. So I think you still have capacity planning in your heart somewhere. So what is your thoughts or about putting capacity planning in? What will be the dimension that people should consider when they want to implement that in that space? You're muted, Fabio.
You're right. So it's capacity has been something we've been working on for quite extensively, and we came up with this concept that Luca was mentioning about business-oriented capacity management that was really good for us. So capacity is going to be very complicated, as I think Alexandra said before. Probably hybrid models where you combine a little bit of modeling with a bit of testing and metrics is the way to go, because the complexity of pure modeling is too high and the complexity of measuring everything is too high. So probably a compromise in between where you mix a lot the two aspects is going to be the best solution. For sure, it really depends on the application. So I think multiple times we mentioned different verticals that have completely different requirements. One thing that we didn't mention before is that probably is the best thing about microcontroller is that they can be very precise at measuring stuff. So we can reach easily precision of micro or nanoseconds when it comes to timers. So if you want really to understand what is going to happen, independent of the way how you transfer this information from the source to the destination, but at least you get a precise number. So this is better than computers in many ways, and this is a positive thing. So yeah, I think that capacity planning is going to be very interesting, because you have to take into consideration not only the performance dimension but also the service level dimension. So just to give you an example, typical application of IoT embedded devices or more sophisticated devices, because there is power, are the street lights. Street lights is a typical IoT application. A lot of LEDs. They do telemetry. They have cameras. They have sensors for the environmental stuff. So a normal light pole in Germany has like 500 euros worth of sensors. On average. So there's a computer with a lot of power inside. So, but then doing capacity planning of the firmware update. So when I do the update, what can be wrong? What is the risk analysis? I think the holistic approach in IoT becomes more important than IT, because in IT you have some application when you do client update and client management that is delicate, but in many cases you manage servers. So the damage you do is a centralized damage, and also recovery is a centralized recovery. If you make a mess or a mistake in a firmware update on the street lights and put the wrong firmware, you end up with dark roads, with all the dangers that are connected to these kind of things. So I think that the next generation of tools for performance and capacity should be much more holistic, And but it's difficult, to understand from scratch what to do. So in my opinion, what you have to do as vendors of these kind of technologies is to start gradually and create some MVP, work with the customers very quickly, iterate, because we can speculate for ages, and then always there is the devil is in the details. You don't have power, you don't have the bandwidth, there is no CPU cycle to allow for these metrics to be captured. So I think what we need to do is to start gradually with these experiments and understand, okay, we are deploying this thing for road safety. The major constraint is time constraint. So we want to make sure that the network is able to respond within milliseconds, nanoseconds, because it's a 5G network, and then work on that condition. And work with a few vertical and try to understand if there are some commonalities that can be factored in order to create more complex solution, not trying to boil the ocean, because this is a real ocean. A problem that can be done, the very typical problem for personal devices, Bluetooth power, could be totally relevant for street lighting, that can be relevant for GPS and asset tracking. And then you find out that the GPS problem is going to be similar to ultra wideband or Bluetooth-based indoor location problems. So unfortunately, IoT is very fragmented. If I can say from our experience, at least from the Arduino point of view, we have seen some sectors where it's much easier to do experimentation. For example, smart agriculture. We're working a lot in smart agriculture. And it's an area where there is more flexibilities because, farmers are to some extent craftsmen and artisans. So they want to tinker. They're open to tinker with performance, with reporting, understanding data, monitoring, measuring. They don't do this normally, so they are very excited when we talk about this kind of thing. So this could be, for example, especially in the US where you have these large farms, or France as well is a huge country as far as technology applied to farms and IoT for farming. And there, I think there is a lot to say as well. So I don't know if I answered your question. It was a complicated question, but I think that a pragmatic approach where we leverage the different aspects and we try to combine models and measurements is the way to go.
But for us, I mean, for a performance engineer perspective, I think, at least for me, I don't know for you, Alexander, Gayatree, Leandro, and Luca, and Jahn, I've been involved in most of the time on either connected houses, connected buildings, connected cars. That are the main or smart warehouses, but that are the main implementation that we are involved in, because at the end of the day, there's business or there are life involved. But yeah, farm, and I know that they were using IoT, but never thought about. I've never been involved in farm IoT testing. That would be pretty cool to measure and say, hey, you have to milk the cow, or you have to pursue to tell the cow to go back, and hey, you have to milk yourself. So that will be that is an interesting topic for sure.
Automated cow milking.
Yeah, but the watering is one of the key problems, because you have crops that cost millions of dollars.
Yeah.
So the watering is a big issue in farming. Also, managing all the stables. It's quite complicated. Also, for example, we did this device. It's a strange application, but it's nice because there is a multinational company. They have a big headquarters here in Italy. It's called Kobo. You should check them out. So Kobo develops a lot of CAN-bus-based devices. So CAN-bus is the protocol that is used in our cars, but also tractors. They have a version of the CAN-bus called the ISOBus. So tractors measure a lot of things. So this company specializes in making retrofitting devices for existing tractor, where you, for example, understand what is the implement that you mounted on a tractor to do a specific job. And in combination with an Arduino board that provides connectivity and GPS sensors, they can do crazy things like, geofencing. So for example, if the driver is driving a tractor in the wrong place with the wrong implement or with the wrong chemical, you can create a signal on the console of the tractor using the this device saying, okay, where are you going? You are not supposed to go there. You are refilling, or you put this implement, but you are supposed to be in another place with a different chemical or something. So it's quite funny how many applications you can see in agriculture that we are learning every day. And another thing that is important also from the performance point of view, what we have seen is that in many cases you combine microcontroller-based applications that are continuously running, for example, with high performance cameras, high quality cameras for situational awareness, even in the tractor. So the tractor works with just sending 1 byte every 15 minutes or every minute on the position to the central location. But then if something happens, then they turn on a high quality camera that connects with 4G or 5G if it is available, or just record on
a SIM card.
A SIM card or a smart card, whatever, some videos. So those applications are complicated from the performance point of view. Even insurance, for example, if you look at all the black boxes and all those things, given the quantity of car accident that you have, and the timely nature of this kind of workload, so it's very important to keep the video synchronized with the sensor data. So in these cases, there are special cases where accurate performance modeling is required. I think London, the UK, London area, Italy, where we have this huge amount of insurance frauds. Those are places where these black boxes and cameras are quite popular. So in that case, it's a real combo problem. So even more complicated than the one before, because you have the embedded part for the sensors, but you have also the video and performance and reliability of the stream and timely nature of the delivery response and things like that. So it's a huge, fascinating world. We are now trying to help people to start building those devices, because the promise of trillion devices is still on Gartner paper. We do sell millions of devices, but we're not on the trillion kind of level that we want to be.
Jahn, you wanted to add something? And I'm looking at the watch. It's 1/4 past, so we almost time to start the conclusion, because I know that we are used to chat a lot. So 15 minutes, I think it's gonna. I know it's gonna be enough for the conclusion. But yeah, Jahn, go ahead.
I'll comment and conclude. How's that? Probably. It's really been a great discussion. I mean, it seems that so much depends on what the IoT device does. I can see in a lot of situations that there's a huge desire that it can operate as an independent unit as much as possible, and also what telemetry is it sending? Is it outbound? Is it inbound? I get the feeling perhaps a lot of IoT devices, most of their telemetry is outbound to a gateway. And is it sending sort of keep alive, I'm still here? Is it sort of media type data that Fabio was referring to? Is it streaming data back to some central media store? And that has such a bearing on what you actually, from a performance and capacity perspective, what you're actually likely to need to test. And I think that's, I mean, the sort of the gateway concept is pretty common in IT, whether it's data coming from somewhere, whether it's a mobile device, an IoT device, and as Gayatree was saying, it's a common requirement to test the capacity of a gateway to deal with incoming traffic, wherever that may be coming from. But of course, in the IoT world, as I've said, it's very much a situation by situation in terms of what the device is designed to do, how much it keeps on board, how a bit like a space probe, how independent it can be, and how often it needs to exchange data. I mean, again, from Fabio saying, the challenge pushing out firmware updates, keeping the software current, making sure that when the update is pushed out, it is applied correctly, so you don't end up with dark streets, as you're saying, updating street lights, what have you. It is a very, very different spin on things, and it really it makes the understanding of exactly what you need to test from a performance perspective, quite challenging. When you compare it to sort of more the traditional performance testing or static performance testing model of some server, some cluster of servers being able to deal with an incoming load up to whatever volume. This is certainly a different world, and it's fascinating, and it's been a lot of things to think about. There are a lot of links I will look at, so thank you for everyone who's put things on the chat. Alexander and Fabio and Henrik. So I guess that's my bit.
Alexander, what will be your thoughts, your final thoughts for this meetup?
So I think that the term may be a little bit misleading. When it was introduced, it makes sense, but now IoT means that just very complex system, including some edge devices. So basically, it may be everything. So talking about performance of IoT, same we can say performance of computer systems in general. So it becomes too wide. So if we want to make it more meaningful, probably we need to specialize. If we talk about specific system, we need to understand its architecture, what is challenges, how every part works, because in every IoT system we have many parts. So first analyze it, each part of it, and then get back to the whole system, because all these parts work together. And probably it's now more specific to specific architecture and use of that system, and maybe we need to concentrate on specific system instead of discussing it completely in general.
Luca?
Yeah, I think the most interesting thing is that thinking about also Fabio said and is the fact that the market lack standards in some specific KPIs, metrics, and so on. So I think that a good idea could be try to merge the experience coming from the performance world and the experience coming from the IoT world in order to set up a standard or help creating community or something like that will help in terms of make our job easier, because we understand better and better what is IoT, because I think we now, as Alexander said, it's a huge and complex world. So it's greater than what we usually as standard performance tester think, I suspect. And the fact that there's a space to create standard also will help the IoT world with our experience in order to get better and better devices, implementation, infrastructure, and so on, thanks to our experience in performance. So maybe the best thing that came up for me is exactly to the fact that there's a space to create something in terms of standards, communities, and so on.
Great, thanks, Luca. Gayatree?
So my final thoughts, but I think these were to be the first thoughts to get started on the IoT of the performance. And the world, the performance world in the IoT space is kind of nascent, and started to learn more about it. So main thing is, as everybody knows, it's a complex system. So breaking it down into a simple Lego pieces and trying to understand, prioritize them, and what is most critical aspect in this whole chain. So that is another major aspect, and trying to understand whether these are connected from device to device, device to server, or server to server. So just understanding these and trying to see which is a priority and what is a critical aspect to it. If it fails, what happens? If it doesn't, and what's the optimum, and again, the other metrics that it needs to be monitored. These are some critical aspects, and this is how we can take it forward. Thank you.
Great, thanks. Fabio?
I know, I think I talked a lot. So just one final remark, because I noticed you have this Amazon reward. So we didn't think, Luca, about it before, but maybe if you have the names of the people that attended, what I can try to do tomorrow is to get our store people to create a discount code for this meetup, so that you can so that you can access the store, the Arduino store, and get some of the nice connected products that we have for a very nice price for you. Sorry, we didn't think about it before. My apologies. So jokes aside, but I will let you know, Henrik, so that you can share it with the rest of the group.
Awesome.
But other than this, I think that there is a huge need for this kind of thinking in our space, in the IoT space, because people are very focused today into getting things done, and sometimes they lose a little bit of focus on the operation aspect, manageability of the asset that we are putting together. So the things that IT went through in the last 20 years, in this case, is just starting deploying stuff, and then security is secondary in many cases. Sometimes they have security breaches, so they reconsider security, and then performance will start, because people see that you have a fleet of 200,000 cars and they are not getting updated on time, and things like that. So it's very important that your community start working with the embedded community and the IoT. Of course, not on all the problems, maybe selectively. There are some standards. Luca was mentioning the standard. There are some standards, but still not something that has been really thought about related specifically to IoT. Different categories of IoT problems. They are always sort of born for large computers kind of things, or large protocol, or large footprint. So it would be very nice to understand if there is something we can do, and we can help for sure promoting the efforts that you may want to do to our community. We have 30 million people visiting our website every year, so it's a huge community. So we would be happy to socialize and to help with our energies to if you do something.
Awesome. That seems very promising, and we already have a meeting planned in Como Lake at Luca's house soon. So we will also combine that with that discussion. Senor Performo.
Okay, well, I think I'm going to be all over the place with my final review, because as everyone has mentioned, IoT on one hand is everywhere and can be counted to require lots of skills. And with some of the comments, as an example, what Alexander said, I think that for performance in terms of the IoT, again, there's one hand on testing, there's another hand on optimization, there's another hand on load testing, and multiple other practices when it's different depending on the device that you're going to be testing and assuring, where I do believe, as an example for what Luca was saying, that now that we have way more resources, lots of RAM, lots of computing power that we can use, I think those have been, because as I was saying earlier, we have tinier devices, less power, we should be more mindful about them. We should take into account things that we have forgotten for ages: CPU queuing, temperature, heating, power consumption. That makes me wonder a little bit when Luca said, yeah, now we have lots of power. And like, yeah, but why did we just stop taking care of it or being aware of it? Just because we have lots of it, we're gonna just waste it. And on one hand, that's the reason why most of us performance testers deal with so much, is because development had forgotten of those cares that they should take into account when they are working. They are probably just working on some Java code that needs to insert something on a database. And if that code needs to be run on a smart device, on a fridge, or elsewhere on an Amazon microwave, it needs to be severely optimized. And generally, the developers are not thinking in that. And on those levels of optimization or specialization, from what Fabio says, when you are a developer creating code for these type of IoT devices, the SDKs for the Raspberries and for all of these tiny computers that we have, the developer has to have a performancer hat on at the moment that is being worked, and that any code is put in the device, so that you guarantee that it's not burning up, killing the battery, or having unwanted consequences. And makes me think, why do we have to just be careful there because we have the limitations, and not on the server side when all of these IoT devices are going to send a request when multiple, many of them are trying to communicate for any reason. The microwave wants to know from Alexa if it should start cooking the popcorn. It's just a yes, no response. Why do I need just to give a weird example, a 50 megabit RAM consumption service just for that microwave to be able to touch base and say, hey, should I start the popcorn now? So many of those layers of the server side solutions as well, I think, need to be optimized severely and start to treat them like if they were an IoT device, and not to waste so many resources. Because in the end, as it was mentioned even before, in the space age, when the US put a man on the moon, they had just this computing power, probably even less than that. And they managed to put the man on the moon because they were so mindful of the capacity and the performance of the device. They were taking into account every tiny bit of information they could process to not to hit it. So gladly, IoT will make us be more conscious of this. And I hope that everyone starts to be more mindful of being not wasteful and perform.
So thanks, Senor Performo. I think there's something that we discussed before we started the meetup, and I just forgot to mention about it. We talked so much about power consumptions of the device, and now we are always thinking of how many nodes we are utilizing not in IoT space. I'm just thinking on more normal development. And I think even the power consumption should be a KPI that somehow we should push back in our reports, because maybe in 2 or 3 years, there will be a notion of, is that application green? Is it utilizing a lot of power? Would I need more? Because I know that a lot of companies similar to Facebook, they are building green data centers that could consume less power.
I may interrupt you. Just a quick example. I dare you to check how long does your laptop's battery will last with 10 Chrome browsers open and tabs.
That's true.
You can tell the difference right there, and that should be a big KPI.
Or even four Selenium scripts, but that's but yeah. So the thing, yeah, sure. I think this even in the IoT, it makes this KPI is super important. This is something we're not tracking, but I think we should somehow find a way to expose that metrics, and we should also report it somewhere in our reports, because it will be a meaningful KPI for any type of implementation, not only IoT. I think there were so many things to discuss today, and I think we could continue this conversation almost 3 hours, because we only scratched the surface. We only touched the sensors layer, almost didn't touch most about the backend, and I'm a bit frustrated about that, but never mind. That's also we have to limit to a certain duration, otherwise it will be boring for everyone. Thanks for everyone to be here during this meetup. I think it was a pretty awesome discussion. Thanks, Fabio. Thanks, Senor Performo, Luca, Gayatree, Jahn, Alexander to be here. So we are going to look at the topic that you have submitted tonight, tomorrow morning or tomorrow afternoon, and we will select the theme that we would like to discuss next week. So if you want to hear more about performance, stay tuned. Next week, next Wednesday at 9 p.m., we will follow again another meetup about performance testing. Thanks again. Stay safe, stay home, and see you next week.
Thank you, amigos. Have a great day.
Ciao.
Adios.
Adios.